Hello, this is going to be a brief and somewhat high-level presentation about state channels. My name is Mike Kirshner. I am part of Team Magmo, and Team Magmo is proud to be part of Consensys Mesh R and D. Team Magmo is four folks: George, myself, Alex, and Colin, and all of our code is open sourced. To become a part of our open source community, check out our GitHub. Let's start with a bit of background first. So traditionally, we talk about the blockchain trilemma. There's three really nice properties that we would like to have: decentralization, scalability, and security. And traditionally, with blockchains, we could only have two of these properties. So let's see if there's a world where we can have all three. So layer one and layer two terms get thrown around, but what do these things concretely mean? Layer one is the underlying blockchain. It can be Ethereum, it can be Bitcoin, it can be Solana, etc. Layer two is something that usually anchors itself to a layer one blockchain. So popular layer twos are Arbitrum, Optimism, TYDX. Layer two activity has been growing tremendously over the past couple of years, and specifically, this is a chart that shows the past year. The blue line is Ethereum mainnet transactions, and the red line is all of the layer two transactions combined. So you can see that in the past year, layer two transactions have surpassed layer one transactions and are surging, especially recently, surging up. So what are state channels? How they fit into layer one, layer two, layer three, etc. The sentence is a bit of a mouthful, but I'm going to read it anyways. A state channel allows a group of mutually distrustful parties to execute an arbitrary application amongst themselves while bootstrapping trust from the underlying blockchain. Let's start with the last part of that sentence. Bootstrapping trust from the underlying blockchain is what most layer twos do. So state channels is sort of adopts a similar technique to other layer twos. Group of mutually distrustful parties means that this is a decentralized technology. There's no admin here. Arbitrary application means that state channels are generally programmable. So these are not geared toward a specific application, but can cater to many different types of applications. Let's define state channels in another way. They are a layer two scaling technique for Ethereum, but really can be applied to any blockchain, and they enable trustless, instant, and zero-fee transactions amongst fixed groups of users. The sort of big strength of state channels is that instant and zero-fee part. State channels can be constructed to so that participants interact at the speed of the network, and there's really no transaction cost for updating state in the state channel. A really compelling use case for state channels is streaming payments. So this is a set of steps that describes how in a payment network, node A can connect to node B and establish a direct channel. So initially, node A needs to perform one blockchain transaction to connect to the network, and node B needs to do the same thing. After that, no more blockchain transactions are performed. If node A wants to establish a direct payment channel with node B, in this case, a couple of intermediaries need to be involved to establish that payment channel. Once the payment channel is established, payments are streamed directly from A to B without intermediaries involved, which is really powerful. So what are the state channel pieces involved? There's actually not a whole lot of technology that backs these things. There's an on-chain contract that locks up assets. There's signed states that are exchanged off-chain. And there's an adjudicator, a judge, that is also a contract. Oftentimes, it's actually the same contract as the asset holder that can resolve disputes. Let's talk about a simple payment channel, just to give you a little bit more of a concrete idea of what happens. On chain, we have an adjudicator. Off chain, we have two participants, Bob on the left in the hat and Alice on the right. So the first thing that Bob and Alice do is they exchange and sign a state. And this is sort of an agreement of what each of them is going to deposit into the adjudicator. After the agreement is signed, Bob and Alice deposit the tokens into the adjudicator. And then they can continue to exchange as many states as they want to update that payment channel. Maybe Bob is providing some sort of service and Alice is paying for that service, or maybe vice versa. When Bob and Alice are done, they publish the state to the adjudicator, and they can split funds based on that state. So there was one blockchain transaction to open the channel and one blockchain transaction to close the channel. This is a very simple, what we call a direct payment channel, and payment channel networks can get much, much more interesting than that. So you can see that at the end of this interaction, the appropriate number of tokens is distributed to both Bob and Alice. So why is this stuff relevant? Why is it interesting? So this is a chart that shows the payment volume and payment count through the Bitcoin Lightning Network. Bitcoin Lightning is a payment network on Bitcoin. It uses this technology called hash time locks under the hood. And you can see a tremendous growth of Lightning over the past year and a half. So payment channels have become very relevant on Bitcoin. And the hypothesis is that on Ethereum and potentially other chains, payment networks will also become very interesting for things like paying for services, paying for content storage, etc. What is a good fit for state channels? Initially, when state channels were envisioned 5 or 6 years ago, people thought of state channels as a generalized layer 2 solution. So we thought of state channels as a way to scale Ethereum. We're backing off a bit off of that now. Rollups, optimistic rollups, zero knowledge rollups are proving to be incredibly powerful. Ethereum has the rollup centric roadmap where the way we're going to scale execution on Ethereum is going to be through rollups. Now, state channels have a great fit when we have the need for high frequency and basically no cost transactions. If you have 1,000 transactions per second, rollups will still not fulfill the need for that kind of throughput. This is where state channels come in. It also should be noted that state channel transactions and interactions are fully private. So if there is a need for full privacy, this is also potentially a technology to be used. And the final bullet point sort of plays along with high frequency. There's also these state channels also are a great fit for very low latency applications. So our team has been collaborating quite a bit with Filecoin Retrieval Market. We were very fortunate to receive some funding from Filecoin. Filecoin is growing into becoming a robust marketplace for file storage and retrieval. And this is sort of a perfect case where folks will be frequently retrieving popular content, and high frequency payments will be important in this marketplace. So we are currently integrating the technology that we've built with some of the Filecoin retrieval projects. This is a demo of what we're calling Web3 Torrent, and it shows off payment channels in the WebTorrent content. This demo is a couple years old, but it's still sort of interesting. What happens in this demo is we have 3 nodes. So in this case, they're just browsers. And all of these nodes connect to the payment network. So on the left, you can see currently one of the nodes depositing funds into the network in order to be able to interact with that network. The node on the left is going to upload a file, and then the nodes on the right will be downloading that file. The nodes on the right will be paying for those file downloads with ETH, in this case, test ETH. And so we'll be able to see sort of an example of really like a high throughput use case. So what we see right now is the node on the left has uploaded the file. It has connected to the payment network. It is ready to share that file. The upper right node is still connecting to the network. You're seeing MetaMask pop up, transaction being completed. And after that's done, we'll sort of see the bytes starting to fly around. So the green bubbles that are on the left are showing payments received, and the blue bubbles on the right are payments sent. You can actually see the interesting case that after the node on the upper right has downloaded some content, it can also start receiving payments for that content. So it is actually also starting to share out that content and get paid for it. So if you're interested in checking out this demo, head on over to web3torrent.statechannels.org. We would love it if you connected with us, if you find this stuff interesting, or if you think you can use state channels in your application or service, then we would love to hear from you. Statechannels.org has our contact information. It has links to our GitHub, links to our research forum, and you can reach out to me directly as well. We look forward to hearing from you.